Welcome to Talkcast and to the final regular episode on my discussions of Chiara Marletto's The Science of Can and Can't. This is Chapter 7, titled A Journey There and Back Again, which, as a Tolkien fan, evokes for me the subtitle of Tolkien's book The Hobbit, and that subtitle was There and Back Again. In the universe of The Lord of the Rings, The Hobbit was actually written by the Hobbit Bilbo Baggins, and it was called, in that universe, There and Back Again. And here in this final chapter, I can draw a couple of parallels between Chiara's book here, as well as Constructor Theory more broadly, and some of the themes in Tolkien's work. Now, before I begin, the first thing to mention is that for viewers on YouTube, for example, but not for listeners, we have something for viewers just to look at. And don't worry if you're simply listening on audio podcast, as this will make no difference to the substance of today's episode. But I have provided some vision, simply because, well, we're talking about a chapter titled A Journey There and Back Again. So I thought it might be nice to have some video of some of the journeys, or walks, I take frequently on the south coast of Australia near a place called Sanctuary Point. This place is interesting because it demonstrates a certain dichotomy in a rather beautiful way. Some people like to be surrounded entirely by civilization, to live as close to the centre of a city, for example, as possible. That's not really me. Some people like to live entirely surrounded by nature, and that's also not me. I like those places that are really on the border, where just behind you is civilization, and you're in it, but you've also got a view of the entirely undeveloped and natural environment. I like to be able to see what hasn't yet been developed, but might be, it could be. The so-called natural environment and the built environment coexisting side by side, places where humans have constructed by turning the resources they've identified into dwellings and roads and whatever else, and the places so far undeveloped. Tolkien's work is rather pessimistic in this regard. He was one of the first greenies, I suppose. He saw industry, broadly speaking, as a blight on the landscape, and all of his works from the Silmarillion through The Hobbit and Lord of the Rings have at their heart a message about decay and the loss of nature. Corruption was what he was often on about and mentioned in his books, and what he seemed to mean by the word corruption, rather often, is something about where technology of a kind came along and ruined a natural forest or something like that. It's not exactly a picture we get of the world that I explain here. It's quite the opposite. Now, of course, Tolkien he spent his formative years in the First World War, and so he saw the destructive aspects of technology, and so that has coloured his view of the impact of humans on the environment, of course. And he lived through a time when he was no doubt witnessing the rapid pace of change in parts of rural England, what the green countryside went through in places where coal mines and the burning of very smoky, unfiltered stuff in order to lift people out of poverty was occurring. Economics is not something he really focused on in Lord of the Rings, but I digress. Just to say that the vision for today's episode, the videos that viewers are seeing, exists to give people something, anything really, to look at. But it's not entirely random. It does give a sense of a journey, and it does provide something of that dichotomy between the natural environment and those places where human knowledge has transformed the world into something less hostile. The other thing to notice here is that being Australia, for most of these video clips, you can get some sense of the proportion here of the undeveloped part of the country, which is the overwhelming majority of the landmass, and these little specks of development we call cities and towns by comparison. Nature has constructed almost everything we still see if you step beyond your tiny city. Humans have just begun to scratch the surface of the landmass that is Australia, to say nothing of the rest of the world, or the solar system, let alone the universe. It is so very early in the history of humanity, we have had almost no impact. Yes, I know, unpopular opinion. Apparently we are uniquely destructive, and we are almost at a tipping point where the damage we have done will be irreversible. I know. Of course, I do not view human activity as damaging. I view the environment and the cosmos as damaging to us, lethal even. We build and construct in order to provide some scant protection against the forces of nature arrayed against us, whether those be cosmic in the form of asteroids, supernovae, long-term climate changes, or more urgently, just catastrophic weather events like floods and storms and fires, or other natural disasters like volcanoes, earthquakes and tsunamis. Planet Earth is a veritable death trap without our energy, technology, and explanatory knowledge, helping us to scratch an existence out from this otherwise implacably hostile rock. I've made the point before that if we don't do what we can to control the environment, it will control us and eventually destroy us and everything else on the planet. That's simply a logical consequence of what we know from physics and science. Either the asteroid's going to hit us, or the sun's going to engulf us, or at least expand so much the oceans boil, unless we learn what to do about all this. The kangaroos aren't going to do it. The bacteria aren't going to do it. The trees aren't going to do it. We need to create fundamental, far-reaching knowledge now, which is one reason I read this book about Constructor Theory. Purportedly, the most fundamental theory of physics we now have, or at least one of them. And that book comes to an end today. This is the first popular science book to have been written on Constructor Theory. It may not be. It should not be the last. It may be that Constructor Theory reaches into areas of science and philosophy and much more in such a way as to radically transform our understanding of physics and life and ourselves that we can use it to solve some of the biggest problems. This final chapter is an excellent one for bringing together the previous ones because it serves as something of a summary of the rest of the book, and then it looks forward to what we can hope for with Constructor Theory off into the infinite future. And well, let's just get into it. Chiara begins in summary with, quote, "At the beginning of this book, I made an ambitious claim. I promised to present a new perspective on physical reality by explaining how to understand and think in terms of counterfactual properties of physical systems. It is now time to head back to where the journey began and to contemplate the new understanding that we have gathered along the way. With the last page approaching, one has to operate like a thoughtful traveller nearing the end of their journey. Review the things that seemed noteworthy, consider what new avenues they open up and whether they are fuel for the creation of further knowledge." The central motivating idea of this book is that a class of properties has been largely neglected in science and that this needs to be remedied because it is preventing progress on fundamental problems. I called those properties counterfactuals. They are not specifiable by describing the actual state of a physical system nor its law of motion. To specify them, one has to describe the system in terms of what transformations are ultimately possible or impossible to perform on it. As I have explained, counterfactuals are lurking at the core of most exciting open problems in fundamental physics. I mentioned several examples. The interoperability of information, chapters 3 and 4, the no-cloning property and the reversibility of quantum information, chapter 4, the resilience of knowledge, chapter 5, the conservation of energy and the distinction between work-like and heat-like energy transfers, chapter 6, and the information-based interoperability of work media and thermodynamics, chapter 6. The main counterfactuals we have explored in this book are summarised in the table that follows, and I'll read through the table. So we've got the phenomenon of information. The counterfactuals involved are the possibility of flip and copy. The physical laws involved are interoperability of information media, and the notable related entities are the universal computer and the universal constructor. Let's pause there and just mention, when Chiara says interoperability, my understanding of that is substrate independence. What that means is that when you've got an information media, it's independent of the physical characteristics of that particular material. So you can have the same information written on a piece of paper. You can have the same information painted onto a window, presumably. You can have the same information represented in the pixels of a computer screen or in the memory of a computer hard drive and so on and so forth. In the mind of a person, indeed, as some arrangement of neurons in the brain. So this is interoperability. The same information can exist in different physical forms. Another phenomena that Chiara mentions is quantum information. The counterfactual involved there is the impossibility of copying certain information-carrying states, the possibility of reversing any transformation. The physical laws governing this, again, is interoperability of information media, and the notable related entities are the universal quantum computer and the universal constructor. The next phenomena that Chiara went through was knowledge, which she defines as resilient information. The counterfactual involved there is the ability to enable transformations and of remaining embodied in physical systems. The physical laws for knowledge have not yet been discovered, but the notable related entities are abstract catalysts and the universal constructor. And the final phenomena covered was work, and the counterfactuals involved there were the possibility of seesawing transformations and the impossibility of changing energy without side effects. That's the conservation of energy. The physical law involved is the conservation of energy, the interoperability of work media, and the counterfactual second law of thermodynamics. And the related entities are the scale-independent heat engines. Scale-independent means it doesn't matter whether it's big or small, and the universal constructor once more. And then she goes on in the text to say, quote, having now an overall perspective, one might notice that two general facts emerge, the two overarching ways in which the power of counterfactuals expresses itself. The first is that adopting counterfactuals brings entities that look superficially like immaterial abstractions into the domain of physics. Information and knowledge, for example, have been traditionally considered as mere abstractions, as things that do not belong to the physical world. However, by considering the counterfactual properties of physical systems that enable information and knowledge, one refutes this idea. Because whether or not a physical system has those properties is set precisely by the laws of physics. End quote. Yes, and so whether or not something can generate knowledge or can contain information depends upon whether the laws of physics say that entity can do so, and indeed what the limits of knowledge creation are is bounded by what we know about the laws of physics. So although knowledge is an abstraction of a kind, it must be instantiated somewhere to count as knowledge. If you can't instantiate it, it doesn't count as knowledge. And that includes inside your mind. So if you have knowledge in your mind, obviously it's instantiated there in your brain. It's represented somehow, encoded. But that encoding process is a physical process. Okay? This is related to the mathematician's misconception that I've spoken about in Topcast over the last few weeks and months. We cannot divorce, therefore, epistemology from physics in any way, shape or form. These things are intimately related. Now, precisely what the relationship is and what laws of physics will come to bear on the possibility of generating knowledge, we don't know yet. We just know that it must, in principle, be bounded by the laws of physics in ways I've mentioned, but in new ways as well, yet to be discovered, which hopefully Constructor Theory will have something to say about. Let's continue. Chiara says, quote, the other fact is that embracing counterfactuals allows one to express exact laws about entities traditionally considered as approximate, because these laws refer directly to the macroscopic world, such as information, energy, heat, and work. When the counterfactual properties enabling those entities are made explicit, it is elegant and easy to express laws about the systems displaying those properties without approximations. This is how the power of counterfactuals allows one to ground concepts that would otherwise be considered abstract or approximate in exact, fundamental physical laws. The logic of how that is done is the same for all the entities discussed in this book. It is a unifying trait. First, one expresses the counterfactual property that is required of a physical system for it to embody the entity in question. For instance, if the entity is information, the counterfactual properties that the system must possess are the possibility of the flip and the copy transformations. Then one can express regularities about the physical systems with those counterfactual properties in the form of laws of physics. For instance, interoperability laws. For example, a bit of information looks like a pure abstraction until we view it through counterfactuals. Then one notices that for a system, for example a switch, to qualify as a bit of information, it must have two counterfactual properties. One, that it is possible for it to be in either of the two physical states, on and off, and two, that the state on and the state off can each be permuted into one another and also copied into any other physical system. That itself has these same two counterfactual properties. Whether a system has these two counterfactual properties, it qualifies as an information medium. You see then why a bit is not an abstraction, independent of the physical world. Whether or not something has those properties depends entirely on the laws of physics. Unlike, say, whether a given number is a prime number, which does not depend in the least on what the laws of physics are. Those counterfactuals provide the link between information and physical laws. In addition, one can state an interoperability law about the system that is displaying those counterfactual properties. The interoperability law explains why the counterfactual properties, though physical, are not dependent on most of the details of the physical systems. It is because when there is an interoperability law, those properties are shared by a class of physical systems. The details of the systems all belonging to the same class become irrelevant. End quote. Again, that's substrate independence. It doesn't matter if the information media is paper, magnetic tape, pits in a compact disc, whatever. The same information can be transmitted from one medium into another. The details of what the stuff is made of, whether it's paper or magnetic tape, doesn't matter. Now, what matters is whether you can do these flip and copy operations. So I'm skipping a number of paragraphs and I'll pick it up where Chiara writes, quote, "As I have explained time and again, the traditional conception of physics cannot express counterfactual properties. The traditional conception can refer to the state of a switch, either on or off, at any given time, and can predict what the state will be at a later time and why. However, a statement of this kind does not tell us anything about what transformations are possible or impossible in the switch. This is why turning to counterfactuals and related laws is essential to capture the physics of phenomena such as information and the other entities you have discovered in this book." End quote. So it really is a simple but profoundly deep idea. You've got a switch. Okay, so you could do traditional classical physics or even quantum theory and have some prediction about what the outcome of a particular process is going to be. Is the switch going to end up on or off? But at no point do you need to actually say, if you ignore counterfactuals, what the possible states of that switch are going to be. That is a counterfactual claim. Saying it could be in the on position or it could be in the off position is irrelevant to what you're trying to do. What you're trying to do is to make a prediction. And so it comes back to understanding to some extent as well. A whole new mode of explanation, a new way of looking at this situation. I know it's simple, okay, it's a switch, but you can in principle imagine this to be generalized to other more complicated, more interesting situations. But if we're just talking about the switch, one would think if you want to have a fundamental physical understanding of this object, you should want to know, well, it can be in one of two states. And if you're sitting there thinking, this is trivial, yeah, it kind of is. But hitherto, physics mind you, fundamental physics, didn't have anything to say about this. But now there is a way, there is a framework, there is this constructor theory, which allows us to talk about, well, the switch could be on and it could be off. It's impossible for it to be otherwise. It's not going to be something else. There's not some third state. It's on or it's off. And it is able to perform as a bit doing this particular operation. Okay, let's continue. Chiara writes, quote, "There is another unifying aspect of the approach I have been advocating which was foreshadowed at the end of Chapter 2. All the counterfactual properties you have encountered are expressible as statements about which transformations are possible and which are not, and why. A daring speculation is therefore that all the laws of physics could be formulated solely in terms of principles about counterfactuals, and that the laws of motion follow from them as derivative and perhaps approximate properties. Exploring this possibility is the start of an exciting research program." End quote. Okay, so just a little bit on the philosophy of science, I suppose. Chiara says there, this could be the start of an exciting research program. So Popper talked about research programs. Okay, this is the idea that it forms a kind of overarching framework deeper than a particular theory. So although constructor theory is called constructor theory, and it would be testable in a whole number of different ways, what we have are the beginnings of ways in which to conduct scientific research, to find particular laws. That's what a research program is. It's kind of a broader conception. It's almost like a view of science, a view of the way in which physics, in this case, could be done. But of course, constructor theory is broader even than just physics. It reaches into biology, it reaches into epistemology. It's sort of like the physics of those areas. The dividing lines between these domains are, of course, not sharp. But whenever I hear research program being used in this technical way, I immediately think of Popper's remarks about evolution by natural selection, Darwinism, because people would ask Popper, well, does evolution by natural selection count as a scientific theory in your sense? Because in what sense is it testable? People will often say things like, well, clearly evolution by natural selection is testable. Haldane said, the great defender of Darwin was, well, one way you could test this is if you find rabbits in the Precambrian. In other words, the evolution of a complex organism like a rabbit at a time prior to the evolution of any complex life. At the Cambrian period of geological strata, you had this thing called the Cambrian explosion, and then lots of complex life arose after that. But before that, you didn't have complicated life. So if you found rabbits there, this would refute the claim that evolution by natural selection is this gradual process of evolution, increased complexity of life. But in fact, as many people have observed since then, that's not a refutation of evolution by natural selection. If you did indeed find rabbits in the Precambrian, if you found rabbits much, much, much earlier in the fossil record than you expect, that would be a problem, but it would not in any way, shape or form refute evolution by natural selection. It could just mean that, well, rapids evolved more rapidly in that particular place than they did anywhere else. And, well, they still evolved. They still evolved by evolution by natural selection. And there's your fossils. The rabbits in the Precambrian exist there because the best explanation is they really did evolve really, really quickly. It's possible. It's possible. So it doesn't refute evolution by natural selection. So then we've got a problem, don't we, in the history of science or the history of ideas and the philosophy of science. If evolution by natural selection is the deepest theory of biology, in what sense is it truly a scientific theory if we can't test it? Is there any way of doing an experiment which would refute it? What observation would we have that could not possibly be explained by evolution by natural selection? And this is why Popper said, well, it's better to consider that as the research program. It's a framework in which we think about all the different ways in which we can have theories of biology and theories of genetics and all this kind of stuff that is related to the question of evolution by natural selection. Evolution by natural selection is just the underlying fact. It's the only possible way in which evolution can happen. We can rule out Lamarckism, we can rule out creationism. The only one we've got left, the only explanation we've got is evolution by natural selection. So you can't test it. After all, test it against what? There's no viable alternative. So that's one thing to say about this. But even in principle, there's no observation that we can have. Unless you saw, I suppose, the spirit from the sky come down and wave a literal magic wand and create life there in front of you, then you might have something. Although, then again, that entity, that spirit, whatever it is that was doing the magic, the creator, maybe that thing evolved. So if that evolved, well then that doesn't refute evolution by natural selection. You just have to appeal to evolution by natural selection to explain the existence of the creator, I suppose. So maybe evolution by natural selection is unfalsifiable. That does not make it a bad theory. It might make it kind of outside of science or prior to science in a way. Kind of like falsifiability itself. The whole concept of falsification is not itself falsifiable. Certainly a crucial part of science. So is it part of science or is it not part of science? Kind of prior to science. The theory that in geology rocks exist, volcanoes exist. These theories of existence that these things just are, well, they're not falsifiable either. You make any claim of anything existing. So what this has to do with anything is that constructor theory might be considered as the start of an exciting research program, as well as a set of physical laws, or ways of informing our deeper understanding of physical laws. Let's keep going. Chiara says, quote, "To develop it, this exciting research program, one would have to formulate laws of physics about systems displaying the counterfactual properties discussed in this book, and to show that dynamical laws such as quantum theory and general relativity are emergent, derivative approximations following from those principles. This is potentially a whole new avenue for physics, being opened up by taking counterfactual seriously. It is for physicists and other scientists and philosophers to explore its developments in the years to come. A program of that sort is no simple matter. For a start, in order to adopt any of these putative laws about the counterfactuals as laws of physics, one would have to ensure they are testable," end quote. So what Chiara's saying there is that you would need to find laws themselves that are testable, counterfactual laws that are testable. But this is different too for any individual particular counterfactual physical law being testable, which makes it therefore scientific. This is a different question to whether the whole research program that we might label constructor theory, whether or not that thing is testable. Whether the existence of counterfactuals in the world and the fundamental nature of the counterfactual properties of physical reality, the physical laws, whether that is testable, it simply just seems to be the truth of the matter. It just is the case that these counterfactuals exist in reality. That's a research program. But that itself might not be testable. It's sort of prior to the scientific theory itself. It's the thing inside which other theories, testable theories, are nested. In the same way that in biology, all the theories of genetics and the way individual species happen to evolve over time is nested within this broader view of biology as species evolving via the process of natural selection. That just is the case. And now you then use that to see what follows, what specific biological laws you end up, and biological knowledge you end up creating, which itself is testable. Chiara goes on to say and explains what fans of TalkCast will be more than familiar with. But let's just read through it anyway. Chiara writes, quote, "A law is testable if it produces predictions about observable traits of a physical system. Testability, as I mentioned in Chapter 2, is a pillar of the scientific method where a theory that makes testable predictions can be refuted if its predictions are not borne out by experiments. A classic example, as recounted in Chapter 2, is testing a prediction about the speed of a ball of a given mass rolling down a slope with a given inclination. Economics and medicine are two disciplines where testability is problematic because although predictions can be made, it is hard to make repeated experiments under controlled conditions to check the predictions against reality. Physics, on the other hand, is privileged because many of its predictions are testable. Can principles about counterfactuals be tested? Yes, but the process is one step removed from the tests of rolling ball predictions that you saw in Chapter 2. Principles such as the conservation of energy are in general tested by deducing their implications for the behaviour of physical systems that are assumed to obey them. Principles are laws about laws. They are meta-laws. One needs first to have at least two rival theories concerning a physical situation to which the principle purports to apply. For instance, one can consider a model for a pendulum that obeys the principle of energy conservation, for example, a model based on Newton's laws, and then another model that does not, predicting that once the pendulum is set into motion, it spontaneously swings to higher and higher points. Then one performs an experiment with an actual pendulum to test the prediction of one model against the other. In the case of the pendulum, all experiments done so far have refuted the model that predicts that energy is spontaneously created. Whenever it looks as though the pendulum swings to higher and higher points, it is because some nearby system is actually providing the energy to do so, for instance, by driving the oscillations with some mechanical engine, which provides the required energy for the swings. So far, the principle of conservation of energy has withstood all tests performed on it in its domain of applicability. Okay, I'm going to skip a fair bit, and I'm going to pick it up in the chapter where Chiara begins to write about a part of science she is actively engaged in physics, in trying to measure things that obey. Well, you're not really sure what laws these things obey. Maybe they obey the laws of general relativity, and maybe they obey the laws of quantum theory, and maybe these two sets of laws actually make incompatible claims about reality. So this is an interesting place where Constructor Theory can have something to say. Let's read what she says about this intriguing experiment that she's been working on. And she writes, quote, "The principle of interoperability also has an intriguing twist, which allows one to make predictions about physical systems without knowing exactly what their laws of motion are. It is something I have been working on for the past few years. With dynamical laws, the only way to make predictions about what happens when two systems are considered together is to know the dynamics of each of them, as well as how to construct the composite laws of motion. But sometimes one does not know all that. For example, it is still a matter of heated debate whether and how gravity obeys quantum theory. The reason is that the current best explanation for gravity is general relativity, a theory with no quantum information media in it. So we may not have all the tools to describe the joint motion of a qubit interacting with gravity. Yet we may still want to make certain testable predictions about that system." End quote. So that's intriguing. You can read more by looking up Chiara and these gravity experiments. How a qubit behaves in a gravitational field. So you've got a qubit, which is clearly being governed by a quantum theory, but then you're looking at how it behaves according to gravity. So then you've got general relativity. So trying to marry up these two things in such a way as you're observing its behaviour, and so coming to a deeper understanding. And I'll go back to the book and just pick it up where she talked about something slightly different, where she says, quote, Other times, even if the law of motion is known, it is too complicated to follow all the motions of the constituents of one of the systems. This is the case for complex molecules that have so many subparticles that it is impossible to use the laws of motion to predict their behavior. Too complicated, even for the existing supercomputers. In such cases, counterfactuals come in very handy because they allow us to still make predictions, end quote. Yeah, so even if you've got complicated molecules, and we're just talking about molecules, then you can't make predictions about the evolution over time of the system of molecules interacting, just because the subparticles, the smaller particles that make up the bigger molecules, are just too many and too complicated. So never mind when you get to the level of cells made up of millions of molecules, and never mind when you put the cells together and you get an animal, and never mind when the animal gets complicated that is a person, and never mind when you put people together and you get social and political and economic systems. And people think you can reduce these things to dynamical laws. People trying to make predictions about the stock market, and people try to make predictions about people making shopping choices and so on and so forth. We can't do it with complicated molecules. We struggle to do it with simple molecules, by the way. So all this is to say that this traditional conception of physics in terms of dynamical laws that allow us to just make predictions of the evolution of the system over time, well, not applicable when you get more complicated systems. But maybe a counterfactual approach can bear fruit. And Chiara writes on this, quote, "Why? Because they, counterfactuals, hold for those systems irrespective of their details. Imagine that you know two systems each qualify as a bit, but you do not know all the details of their dynamics, nor how to describe the dynamics when they interact with one another. The interoperability of information would still allow you to make predictions about certain tasks on the composite system, because it is based on the counterfactuals rather than on the dynamics. This is an example of how the laws about counterfactual properties can be useful and go beyond the testable predictions of known dynamical laws." I want to mention a very recent example where this logic applies, which is at the heart of the current struggle to merge the two best explanations of the universe known to us, quantum theory and general relativity. There are some physical systems, such as particles with masses comparable to those of human cells, for which both gravity and quantum theory are thought to be relevant. Yet there is no unified dynamical law that describes a system that both gravitates and is quantum. There have been brilliant proposals to achieve that unification, but to date, none of these candidates has been conclusively chosen over the others. When it comes to those systems, we do not know what law of motion we should be using to make predictions. Still, we know that the counterfactual interoperability law applies in that domain, even when the specific laws of motion are unknown, so we can use the interoperability law to make predictions in that domain. This approach with counterfactuals has recently led to an idea to test effects in quantum gravity, which has created a lot of interest within the quantum gravity and the experimental communities. The race to realise the experiment has started, and if it is realised, it could finally refute the idea that gravity is not quantum. Such is the reach of counterfactuals. They provide a powerful underpinning of deep conceptual ideas, as well as the robust theoretical nature to support experimental ideas of this kind. I expect there will be more experimental ideas to come. In addition to the exciting consequences for physics, switching to counterfactuals has deep, important implications for other fields. One of them could be to revolutionise the understanding of knowledge. End quote. And just my reflection on this. This is a purported experiment, by the way. You can just do a Google search to find out more of the details. Just type in Chiara and Vlatko, who's her collaborator on this, gravity and qubit. So they're your four big things, the two authors of the paper and the two concepts we're talking about here. Now, one of the papers by Chiara and Vlatko appears in the journal Nature, one of the most prestigious journals in the world. And you can look up the details there, and they talk about how Feynman was the one who first suggested coming up with some kind of test. And so they've come up with a kind of test, these experiments about quantum theory and general relativity. But now Chiara goes on to talking about counterfactuals and the relationship to knowledge, explanatory knowledge. And she writes, quote, "I said that knowledge is a particular type of information with the counterfactual property of being resilient. It can cause itself to remain instantiated in physical systems. I also explained that we do not know exactly how it is created, but we know that it can arise out of no knowledge via the process of natural selection, and that another process for creating new knowledge is what happens in the brain when we think. Science does not know if there are new laws that govern this type of resilient information, but rooting knowledge in counterfactuals is the right approach to creating a corpus of such laws. This is not least because the approach via counterfactuals frees knowledge from all the subjective connotations that have traditionally plagued theories of it. End quote. Yes, and so this is a Popperian view of knowledge. This is an addition on top of, or goes deeper in some sense than Popper's view of knowledge. But Popper is, of course, an escape from all the subjective connotations that have traditionally plagued theories of knowledge. So he certainly took the subjectivity out of knowledge. Okay, his entire epistemology was to talk about objective knowledge, and I've spoken about this before. If you're interested, one of my episodes is just called Objective Knowledge. It's literally about Popper's view of this stuff. Let's see what Chiara adds to this. She writes, quote, "Moreover, with counterfactuals, knowledge becomes a physical entity, rooted in the resilience of a particular kind of information, which is an objective counterfactual property independent of observers, sentient beings, and the like. The most far-reaching consequence of this shift is that some open problems that have been traditionally labelled as spiritual, mystical, and even religious, such as finding laws and regularities about knowledge and its evolution, can, via that shift, be posed firmly within the scientific domain without appeal to dogmas or supernatural ideas. This is the first necessary step in order to solve these problems via scientific methods, and it relies on counterfactuals." End quote. Yes, so knowledge as useful information, as information that solves a problem, is going to tend to get itself replicated in the minds of entities out there, and indeed, well, in the minds of entities, whether those entities count as living or not. So you could have some robotic system which doesn't count as living by some criteria, depending upon how you define things. It may not replicate. It may be incapable or not want to reproduce, but it still counts as a thinking conscious thing. I don't know. Are all thinking conscious things necessarily alive? Certainly not all alive things are conscious and thinking, like bacteria or trees. But if you're a scientist looking into outer space and you find structures, technologies, industry, buildings out there that have been created by an intelligence, then you found a kind of knowledge instantiated in those industries, that building, whatever it happens to be, the Dyson sphere that you find. You found explanatory knowledge of a kind. And it's not about that knowledge being in the mind of any particular subject. It's not subjective. It's out there having an effect on reality, taking advantage of knowledge of physical laws, knowledge of matter, and so on and so forth. Let's keep going. Chiara writes, quote, "This switch removes from the shoulders of scientists and rationalists a heavy burden that comes with those problems, an apparent dilemma, which goes like this. On the one hand, there are certain phenomena that require explanation. Phenomena such as artificial selection, the unfolding of creativity at the level of the individual, with new theoretical ideas popping up in various disciplines as a result of individual creativity, and of society, with the progress of civilization. We are intrigued by these phenomena and compelled to understand them in depth. Yet, contrary to this intuition, it is often anathema to scientists to talk about the creativity in human brains, knowledge, and related phenomena as having any real significance. This is because of a prejudice that affects the sciences in much the same way that prejudices of other kinds affect religious thinking. Knowledge is regarded suspiciously as anthropocentric, subjective, and related to Descartes' mind-body dualism, which is at the root of all sorts of misconceptions that are also deeply entrenched in religious thinking. As a result, many open problems about the human mind and knowledge creation are sometimes regarded as not interesting by some scientists. The contemplation of the possibility of laws applying to knowledge and the like appears like literal nonsense to part of the scientific community. Some retreat to the domain of reductionism and materialism, denying that knowledge is a phenomenon requiring an explanation. Others simply ignore the question, thinking that it goes several steps too far into stuff that is not proper science. End quote. My reflection on that. Yes, well, some physicists are irrational. Some physicists will say, well, we don't have to have experimentally testable theories. I've talked about that before. Some physicists will say, well, all we need is to have an instrumentalist view of quantum theory. So, well, what particular scientists regard as proper science is of no concern. Okay, science can be universal in its approach to looking at problems. Some problems will be, just by definition, outside of its capacity to really make deep inroads into. So, for example, moral questions. What should be the case? Because science is about what is the case? What is going on right now? How do we explain this particular phenomenon? Now, if you're trying to construct a theory of what should be the case, well, now you've immediately left science just by definition. Or if you want to prove a particular theorem, well, you don't need to worry about the experimental testability of that particular thing. It's independent of science. But for anything that exists, name it. Name your thing. Even the existence of religion, of this thing called religion, that's amenable to scientific study in the sense that you can come up with theories and then you can go out and try and refute these theories. Look in the world to see if your theory is actually refuted by the existence of any particular religion that's out there right now, or ever has existed, let's say. And so too with knowledge, these conceptions of knowledge that talk about knowledge as being just a thing that people think that's just going on inside of human minds. Well, it's wrong, and we know it's wrong because, well, Popper explained, knowledge is instantiated in physical objects. It can be written into books. It can appear in our microscopes and technology. That's knowledge. Knowledge has this objective character. It doesn't matter what particular scientists or philosophers or anyone thinks, okay? People who want to make progress can just largely ignore the gainsayers. Sometimes it's important to just solve your problem, to find the thing that you're interested in and solve it. And whether someone wants to call what you're doing science or not should have no bearing on your capacity to make progress. Who cares what names they call you, I suppose? You're not a scientist. Okay, fine. You're the only real scientist then. It doesn't matter. Let's keep on going on this question of whether or not things like knowledge is amenable to a scientific study. Chiara writes, quote, "But counterfactuals provide a way out of this trouble if we use counterfactuals to define knowledge as information with the ability to last, such as that in genes that code for useful adaptations, and creativity as the ability to create new knowledge. We are able to free them of any subjective tinge, making them objective. This is still very far from providing a theory of those phenomena, but it provides a scientific handle on knowledge by grounding it in the laws of physics." Pausing there, my reflection. Just to say, wonderful, that's great, isn't it? That's very, very cool that we have this physical way, this kind of inroad into knowledge creation and epistemology from physics via constructor theory. Let's keep on going. Chiara writes, quote, "After taking this step, one can make further useful moves. First, consider as a problem for physics the fact that certain systems in the biosphere exhibit a property that no other system in the known universe has, namely creativity. The ability to create new knowledge by thinking. Human brains have this ability. It may be that other systems, say beetroot plants, have it too, but it is at best much less manifest than it is for humans." Pausing there, my reflection. Yeah, I don't know about that. This is one of those areas where we're just saying, postulating that anything like a beetroot plant having the capacity for creativity of that kind. Let's say we should specify the creation of explanatory knowledge. What problem does it solve? What do we notice about beetroot plants? Now, perhaps someone does have the problem. They think that the beetroot plant actually, maybe there is some observation out there that is crying out for explanation in the form of, well, the only way to understand what's going on there with that beetroot plant is it's explaining the world. It's got a problem and it's trying to create the solution via conjecturing explanations. Maybe, we don't know enough. But at the moment, I don't know that we have such a problem. Anyway, let's keep going. Chiara writes, quote, "Now, thanks to our objective definition of knowledge, stating facts like this, that human brains can create knowledge, is no longer vulnerable to allegations of anthropocentrism. Claiming that it is anthropocentric would be equivalent to considering the statement, a dishwasher has special properties among all the known systems in the known universe, as supporting a dishwasher-centric view of the universe. Clearly it does not. It is an objective statement about the fact that dishwashers can do certain things, such as quickly scrubbing away dirt from cutlery and crockery and being unchanged by the experience, to an accuracy that is unparalleled in the known universe. Likewise, the statement, human brains are capable of constructing new knowledge, is not anthropocentric. The relevant difference between the case of human brains and that of dishwashing machines is that the detailed functionality of being knowledge creating is not as well understood as the functionality of dishwashing machines." Pausing there, my reflection. That would be to understate things. So we understand very well to high fidelity to the point where if something goes wrong with your dishwashing machine, You can fix it so that it continue to dishwash. But on the other hand, knowledge creation, we understand basically next to nothing about how it happens. We know that all people do. We know that it's occurring in the brain in some way, manifested in the ideas, which are in the mind, and so on and so forth. But we don't understand, the genesis of any particular bit of knowledge that we create. The brain is doing something remarkably unusual. And although we carry around this head with us all the time, it's almost simultaneously the thing most opaque to us. We just don't know where the ideas and the conjectures are coming from. We just know that we have them. Let's keep going. Chiara writes, still, via the counterfactual notion of knowledge, one can now refer to knowledge creation in an objective fashion. It is the first essential step in regarding problems about creativity as pertaining to the domain of science, which is in turn step 0 to even hoping to address them effectively. Quite right. Another consequence of this switch is that we can consider a number of other related issues as coming into the domain of science. There are several examples. First, there is the issue of whether there are other systems in the universe with the same creative capabilities as the human brain, other species on Earth, other forms of life on other planets, or possibly existing and future artificial intelligence. Related to this is the problem of understanding how knowledge comes into the world, understanding the thinking process and creativity from the point of view of physics and information theory. Starting from our objective definition of knowledge, we can wonder properly within science about such questions as, how can one set up that creative ability in a computer? Is the termination of creativity with death necessary, as some would like to argue, or is it actually possible to defer death to later and later in life by means of some sort of error correction? What is it exactly that we have to store and error correct? Can a person be copied, stored, and downloaded into another embodiment when the time of death for the body approaches? Each of these topics requires very careful consideration, and it could be the subject of countless research programs. Here, I just want to point out one fact. Whatever your view on these questions, it is far easier to approach them from the point of view of science, free of the prejudice that knowledge-related issues are anthropocentric, subjective, and non-scientific. Counterfactuals allow one to take all these issues seriously and fully within the scientific method. End quote. Yeah, and that's great. That's great. Now, Chiara then goes through a couple of stories. One about Alexander the Great that I'm not going to read, and basically at the end of his long journeys of conquest, he comes back to his home and basically becomes depressed because he's done it all. There's nothing left for him to do. So he becomes depressed at the fact that he has nothing left to accomplish, kind of thing. He's profoundly dissatisfied. But on the other hand, Chiara compares this to Odysseus, a figure from Greek mythology, who goes on all of his adventures but comes back excited for having been on the adventures, and he's learned so much and he just wants to do so much more. In fact, I'll just read the end of what Chiara says, her commentary on comparing these two particular tales from antiquity. She writes, quote, unlike Alexander, Odysseus has not lost himself at the end of the story, but has acquired more knowledge and has the ability to put it to some future use. The end of the Odyssey has a firm higher point than its start, which is essential for future improvement. It is richer in possibilities, which are a special case of counterfactuals. Alexander, by contrast, has lost his capacity to dream of further deeds. His creativity and all the knowledge acquired along the way is therefore useless because it cannot be put to any further use. End quote. So this is a wonderful comparison of modern intellectuals. Two ways of going. Be Odysseus. Be optimistic. Learn as much as you possibly can and realize in becoming enriched with knowledge that there is always more to learn and problems to solve, and then this is unending. Don't be like Alexander, the pessimist, who, upon gaining all this knowledge, thinks that, well, it's just about all finished. We've just about discovered everything we can, and in fact, I'm so brilliant and I'm so smart that I've already figured out all of these problems that are definitely going to kill, if not my present generation, then certainly my children or their children's generation, because it's inevitable that humans are going to be destructive. There's nothing more for us to accomplish, nothing to look forward to. Everything is dark and grim. That appears to be this comparison between Odysseus and Alexander, these two visions of reality. And we here like to be Odysseus. We here like to gain as much explanatory knowledge, but realize we're always at the beginning, just scratching the surface, and every problem solved opens up a new vista of just more and more problems. Let's keep on going, because this is now coming right to the end of the book. And so let's read the last few paragraphs. And Chiara writes, quote, "More generally, any journey, without necessarily being literally an exact circle, can still be a successful nostos of sorts, and its end can be a positive, uplifting fact. What matters is whether along the journey the character has or has not managed to create more knowledge while preserving his or her own individual capacity to create new knowledge. So an ending can be a fertile starting point. It depends on whether the character reaching the end is still capable of being creative. In fact, a successful nostos does not have an ending. Its ending is just the starting point of new adventures." End quote. There's still a bit left to read, but I just want to highlight the fact, isn't that reminiscent? Doesn't that echo the beginning of Infinity, and certainly the sentiments of the beginning of Infinity and David Deutsch's worldview? Great to see this influence permeating this book here. Well, it's throughout the book, but here, particularly at the end. Let's keep on going. By the way, Chiara's using this word nostos, which is the Greek for a particular kind of story in ancient Greece, which is a kind of a circular kind of a journey, someone beginning in a certain place and coming all the way back to the start. But as she says there, you don't want a perfect circle. You just want approximately a circle, okay? You solve the problem, and in finding the solution, it reveals more problems. So you're kind of back to the start in a way. You haven't been relieved of all problems. In fact, you've just got more again. But they're better problems, hopefully, by Popper's lights anyway. And as she writes, quote, "Just as with a nostos, there may be no actual ending for a book either, provided that something particular occurs while the reader goes through the book. When a reader makes his way through a book, a unique relationship is established between the book and the reader, which grows within the space that the writer, Philip Pullman, has masterfully called the borderland. The relationship is entirely based on counterfactuals, the knowledge that the reader creates in their mind while reading the book, and it is something unique and private to the reader. Whenever knowledge creation happens while the book is read, the reader undergoes a nostos. Even once the book is completed, implications of the knowledge created along the way stay with the reader for as long as the reader's mind survives and can be put to some use in the future. In that case, the book does not really have an end." Pausing there, my reflection on that. "And moreover, the knowledge that has been instantiated in the text of a book by the author is not always the knowledge that is gained by the reader. The reader has to go through this process of interpreting what is written there on the page, and they may pick up subtly different lessons. And they may even go on to create in their minds new knowledge, which goes beyond what is in the book as well. So this is an interesting feature of the transmission of knowledge or memes that happens between people." Last paragraph, and this is of course where we're going to end it today. And Chiara writes, quote, "As I am writing these lines, I am thinking of you, my reader, like a modern Odysseus. You are now emerging from this journey, approaching the end. You can moor the boat at the wharf, take a well-deserved rest at the hostel that overlooks the harbour, and look back through your memories, considering them carefully. As you are pondering all the ideas encountered in the book, perhaps a smile lights up your face. Before you, there are still vast, unexplored waters waiting for you to take to the sea once more and create further knowledge. May the knowledge you discovered in this book serve you well on the journey." The end. That's the end of the book. And a beautiful way to end there. And hopefully my scenes have captured something of the poetry, especially of this final chapter here today. And so that's the end of The Science of Can and Can't. And yes, I'm sure people will ask, will I have a discussion with Chiara? And no doubt I will at some stage. I'm not sure when, but that will be what remains of my discussions of The Science of Can and Can't, is to speak with the author herself about what's been done since perhaps the publication of this book, and what deeper insights we might be able to look forward to when it comes to the application of constructor theory to our deepest problems. Until next time, bye-bye.